Hello students, in this session let us solve this question of spring. In this question it is given that a closed coiled helical spring made of 10 mm diameter steel wire has 15 coils of 100 mm mean diameter. The spring is subjected to an axial load of 100 Newton. We have to calculate the maximum shear stress induced, the deflection and the stiffness of the spring. Modulus of rigidity is given 8.16 multiplied 10 to the power 4 Newton per millimeter square. So this is a question of closed coil helical spring in which 10 millimeter diameter of the wire is given. Mean diameter is 100 millimeter and number of coils are 15. The load applied is 100 Newton and we have to calculate the maximum shear stress, the deflection and stiffness of the spring. Modulus of rigidity is also given. So let us solve this problem. Hello students, in this question we are given with a closed coil helical spring and the different values are given. The diameter of the wire diameter, this for which this spring is made, 10 mm is given. Number of coils are given 15. The mean diameter from this part, right? Mean diameter from here to here, like this, right? This is the mean diameter, D. The mean diameter given is 100 mm. The force applied on the spring is, this weight is 100 Newton. We have to find the maximum shear stress developed in the material because due to load applied, as we have seen in our theoretical lectures, that there is a torque developed in the material, right? So tau max, due to that torque, the shear stress will be developed in the material. So tau max we have to find out, and the deflection. By applying the load, it will be actually deformed, it will be elongation will be developed, and the elongation we have to find out, and also the stiffness of the material we have to find out, and the modulus of rigidity of the material is given to 8.16 divided by 4 megapascal. So we know some formulas about this. We should know the formulas. The deflection of the closed coil spring is given by this equation. Maximum shear stress is given by this equation, and stiffness is given by weight per unit deflection. So these formulas should be known to us, right? We can directly apply these formulas and find out the values, right? So what is tau max? Tau max is 16 Wr by pi d cube. 16 W we know 100 Newton. 100 Newton. R is the mean radius. Mean dia is given to us 100 mm, so we can write 50 mm. If you take 50 mm, then your answer will come in megapascal directly. Pi d cube. This d is the dia of the wire, and that is given 10 mm. So 10 cube. So this is millimeter, answer will come in megapascal or Newton per millimeter square. So solve it, you will get the maximum shear stress in the material, and the maximum shear stress in the material will come out to be 24.5 megapascal. So tau max is 24.5 megapascal. This is the first answer of this question. Second, deflection in the spring. So this is 64 W. W is the weight applied, 100 Newton multiplied by R cube, mean radius. Mean radius is 50, mean dia is 100, mean radius 50. So 50 cube we are taking in millimeter, so answer will come in millimeter. So 50 cube, N number of tons 15 divided by G modulus of rigidity. If you take this in megapascal, then answer will come in millimeter. So take in megapascal. So in megapascal 8.16 multiplied 10 to the power 4 megapascal. So megapascal means millimeter square. This is millimeter cube. This is millimeter cube, and this is diameter is 10 mm. So the answer will come in millimeter. So we have to take this megapascal in megapascal to take the answer in, to find the answer in millimeter, right? Because it is Newton per millimeter square, so it will come power 5 and this, right? So diav should come in millimeter, so 10 to the power 4. So we have taken the 64 is the value, multiplication is there, 100 is the load applied in Newton, 100 Newton. This is taken in millimeter, the mean radius in millimeter, number of turns is 15. This is taken in Newton per millimeter square, and this is also in millimeter. So answer will come in millimeter. So from here you can find out the deflection in the spring. And what is the deflection in the spring? That is 14.7 millimeter. So the deflection in the spring is 14.7 millimeter. This is one more answer of this question. And the last answer is stiffness of the spring, and stiffness of the spring or spring constant can be defined as weight per unit deflection. Weight is given to us 100, per unit deflection that is 14.7. So the answer will come in Newton per millimeter. So it will come out to be 6.8. So this will be 6.8 Newton per millimeter. So K is 6.8 Newton per millimeter. This is one more answer of this question. So this is how we have find out the maximum shear stress in the spring material, the deflection of spring material, and the stiffness of the spring.